Yeah, so essentially we're here today to talk about what it means to run a distributed architecture in a multi-cloud configuration, and basically everything that goes along with it. Target is, a very large enterprise. John Engelman, who is director of technology at Target, came a couple of years ago and talked about Target Application Platform, which is sort of the foundation of how we approach multi-cloud inside of Target. So we're gonna talk a little bit about that. I'll start off by introducing myself, which will be helpful. So in my current role, I'm the CISO and VP of Cybersecurity at Shipped. This is a fairly new position for me within the last month or so. So when Bridget and I were talking about giving this talk this year, I was actually still working at Target. So as we go through this presentation and I'm talking about multi-cloud, I am talking from the perspective of Target. And when I say things like we, I caught myself a lot in preparation saying we and us and all of that kind of stuff. Just know that I'm referring to Target when I'm talking about that. Shipped has, a very, very different cloud environment than Target does. But essentially, I worked in Target infrastructure for a number of years. I've been on the ground floor of building and developing out and operationalizing and taking to production a number of fairly large cloud environments that have ended up being large-scale productions. And in a previous life, I was one of the original developers on Spinnaker. Spinnaker is an open source continuous delivery platform. It's open source through Netflix, but in collaboration with a number of large organizations who are doing multi-cloud and continuous delivery and so forth. So that's it. There's links to my social media for anybody who wants to connect with me and go from there. No meeting in modern times would be appropriate without an agenda. So I've added a couple of points that we're going to go through and talk about. The first thing I want to do is I want to add a little bit of definition to the term multi-cloud, and specifically what I consider some of the configurations that often fall under the guise of multi-cloud. But I think it's important for us to get some of the wording straight, at least for this conversation. Then I want to talk about a little bit about some of the ground level architectural considerations, some of the practices, the architectural patterns that need to be in place to practically pull off a multi-cloud environment. From there, I want to jump in and dive a little bit deeper into Target's hybrid multi-cloud environment. I want to talk about how Target has achieved workload mobility across clouds, how we've how we've created a constant state architecture, which I'll hopefully make sense by the end of this, and talk a little bit more about how we do data movement, which also hopefully will make sense. And then finally, I want to talk about some of the more advanced considerations for essentially what you can do when you have a multi-cloud environment, and essentially talk about where do we go from here now that Target's built all this out. Before we dive in, though, I want to point you to Richard Siroder's Twitter account. Interestingly, as I was putting this talk together, Richard did a pretty cool series of short interviews with a bunch of industry-leading experts talking about multi-cloud, what it all was, and I just really found the conversations fascinating. So if you get an opportunity, I think jump over to Richard's Twitter and you can kind of dive through his video. I think he did 8 individual videos, but they were all extremely good, so worthwhile to take a look at that. Okay, so let's define cloud stereotypes and add a little bit of nomenclature around some of the terminology. And actually, before we even talk about multi-cloud, I'm going to end on multi-cloud, but I want to start by talking about hybrid cloud, because I suspect that for most enterprises that are not yet talking about multi-cloud or whatever, this is probably the world that you live in. And I define hybrid cloud as something of a mix of legacy and modern environments. And this could be for organizations that are on a digital transformation journey, where most of the business processes are co-located in a data center on legacy technology, and then any of the emerging technology lives out in the cloud somewhere. So you have this hybrid of business critical processes living in a data center somewhere, but then this sort of cutting edge digital operation living out in the cloud somewhere. Now, some of you, like at Target, might also be in a world where there is both legacy and emerging technology inside of your data center, as well as emerging technology inside of the cloud. So that's a really interesting thing about the work that we did in Target Infrastructure, which is that we were also, in addition to working in public cloud, we were innovating inside of a private cloud environment inside of our own data center. So that was really good. And then lastly, in terms of hybrid cloud, some of you may be in a world where this is a mix of cloud and data center and edge and IoT and literally any kind of runtime that you can think of. And I quite frankly find that fascinating and exhilarating. And Target also happens to be in that kind of world as well, where it has all those considerations to go along with it. But essentially, at the end of the day, what you see here, this is the mix of configurations that I think about when I think of hybrid cloud. So next thing I want to talk about, this is a much simpler matrix, I think very easy to understand. This is what we can call single cloud. Single cloud environment is, regardless of what the public cloud or private cloud environment that you're running in, essentially your workload tenants, your workload and your data are co-tenant with one another inside of the same cloud. Your deployment operations and runtime are all designed and sort of pre-molded to understand how that cloud operates and how the service operates inside that cloud. And you consume features that are specific and non-abstract to the cloud provider of your choice. So in other words, if you're running in AWS and you're using DynamoDB, there's a great example. Jumping from single cloud, there's another facet that I call multi-single cloud. And the interesting thing is that I think that this is actually where most people are when they talk about multi-cloud. Multi-single cloud, I think you can kind of get a good idea of what this is. But this is an environment where services are distributed and deployed across multiple cloud providers, but data is co-tenant for the services inside of their individual cloud, right? So the service architecture is able to operate cooperatively across clouds, but essentially each service and its corresponding data is landlocked to its own cloud provider. When you're developing a service in this environment, you develop it knowing that your service is going to be deployed to that particular cloud, that your operations are going to need to reflect the runtime being that cloud, and that every kind of interaction that you have from service to infrastructure knows that it's that cloud of choice. And like I said, through countless conversations and a number of with a number of organizations and other folks, when I talk to people about multi-cloud, this is what they're doing, right? They've got a number of services and they're kind of split up. But I think about that differently than I think about multi-cloud. Multi-cloud, on the other hand, how I would define this is that services and data are cooperative across multiple clouds. And that is a really important distinction from the previous multi-single cloud configuration, because services and data have no practical awareness in this configuration of any kind of locality for their base runtime state, their baseline runtime state. So in other words, in a pure definition of multi-cloud, you could easily imagine a world where one day a service is deployed to AWS, the next day it's deployed to GCP, the day after that it's running on Azure, and then the following day it's running inside of your private cloud environment. This is without a doubt the hardest configuration to pull off in practice, but I hope through this presentation and conversation to give you some food for thought and talk about how essentially we've managed to do this at Target. Addendum, I'd probably add this one in. There is a hybrid multi-cloud that should go along with that. I'm not going to talk too much about that. And these definitions will probably evolve. But let's get right to the big question, right? Is the multi-cloud architecture right for me? The truth of the matter is that there's a huge operational tax for going multi-cloud. And I would say for most small to medium-sized operations who expect to remain small to medium-sized, at least for some period of time, a single cloud deployment is absolutely the right thing to do. And you know, so much so that you can even take that a step further. While you're still in growth phase, a single cloud in a single region is probably even the right thing to do. So think about it from that. I'm not sure that there are enough public case studies of pure multi-cloud environments for me to make a qualified argument about what the criteria matrix you should follow should be when you're deciding whether or not multi-cloud is the right thing for you. But I can share with you a little bit of what our thinking was about going to multi-cloud at Target. We're always thinking about how we can preserve and improve the team member and guest experience overall. And that means doing things in a way that we can ensure high levels of resiliency inside of the environment for both the service and data stacks. And all of this rolls up under something that we call the Target Retail Platform. Generally, we think about the Target Retail Platform in cap theorem terms of it being an AP operational and architectural mindset. So if you're familiar with the cap theorem, you have consistency, availability, and partition tolerance. We favor availability and partition tolerance over consistency at the end of the day. And that means that, you know, for us, reliability of services is pretty much the most critical dimension in our thought process around multi-cloud. And we want to make sure, essentially, at the end of the day, that any request that's coming to any of our services has a path through to completion. And that applies to the full spectrum of what I call the Target Cloud Continuum. I'll also add on top of that we think and talk a lot about latency tolerance, which you could argue rolls up under reliability. But we think about that distinctly because we're an omni-channel retailer. So, you know, you're in the store. We have different latency requirements for requests that are coming from a register inside the store than we do for a user on the website. So we kind of have to design our multi-cloud experience to reflect that. In a little bit here, I'm going to talk about Unimatrix and edge deployments and how they all connect up with our private and public cloud deployments. But I will also briefly introduce you to an ongoing body of work inside of Target infrastructure that we call Maze, which essentially is our next generation of edge architecture. Very, very, very light introduction. I think, you know, that is probably a conversation for the future that we'll need to build out. But essentially, it's building on that hybrid multi-cloud experience overall. You know, broadly speaking, our mindset is that essentially we should be able to complete a transaction regardless of multiple failures in the service stack. And so naturally, you know, when we're thinking about multi-cloud at Target, we're looking to run the Target Retail Platform across IaaS and across PaaS providers. So that's a big thing. Cost is the next thing that we should talk about in terms of consideration for a multi-cloud footprint. And this comes in a variety of forms. Now, what I do want to say is that in a vacuum, monetary cost when considering multi-cloud is probably the worst metric that you could optimize around. Because the truth is that you can always find ways to optimize your service stack or get better discounts from your cloud provider at the end of the day. So if you're going into multi-cloud thinking that you're going to have some kind of cost benefit from doing that, that's not the right thing. But you know, Target is a large enough operation that we can actually fairly easily quantify the cost of running a workload in an individual cloud environment, whether that's public or private, and essentially work iteratively to improve that cost coefficient, which is really nice. But the cost of going to the cloud is really based off of how you do performance optimizations and stuff like that. It's an architectural consideration. It's not a monetary factor, is what I'm getting at. So meeting the high resiliency for team member and guest experience, we need to be resilient to failures at multiple levels, including within the cloud provider infrastructure. Also, that includes our network links, our storage links, and so forth and so on. Over the last several years, the architectural considerations that have gone into the Target retail platform have made it so that we can fairly seamlessly run the same platform and data services on top of disparate infrastructure, essentially giving us the ability to fail requests up and down the stack as any kind of errors occur. And the rigor on the architectural process has given us the flexibility to move workloads seamlessly without having to redesign any of the services, which ultimately, at the end of the day, reduces our architectural costs. If you have ever worked on an infrastructure migration project in the past, you understand that that mostly comes down to how the services are written to run on top of it. So taking it from there a little bit, the main takeaways I think that I want you to have on multi-cloud at Target is that Target being an omni-channel retailer, we need to preserve a very good experience across our digital and in-store experiences. We have compute that goes all the way from a data center inside of every store, all the way out to a cloud presence for our digital operation. Internally, as an internal infrastructure provider, it's also incredibly important that everything that we do is resilient and latency tolerant across the chain. So we look at it through those two kind of lenses. Now, some practical pieces that I think are really important to talk about. Any organization considering going multi-cloud must have two technical practices down really well, and it's CICD and data movement. Most companies have one or the other. Very few companies have both. Services need to be built in a way where CICD encapsulates the underlying runtime environment. So in other words, services should not be designed in a way that they have to understand what cloud they're going to be running in. And I think for this audience, this is definitely speaking your language, right? You can probably already imagine how you would architect a CI job to deploy one Docker container out to two different clouds, right? That's not a very big jump. But the delivery of an artifact out to multiple clouds can come in a couple of different ways. A primitive implementation of this, which again for the multi-single cloud folks I see a lot of, which is essentially adding a script at the end of a CI job that pushes a container out to one cloud and then the other cloud right after that. A more robust implementation would be to use something like Spinnaker. For those of you who have not used Spinnaker before, I talked a little bit about it in the introduction there, but it is an open source multi-cloud continuous delivery platform. Multi-cloud is a really hot topic these days and right now, but we've been building multi-cloud tooling for the better part of the last decade. So Spinnaker is a very far along project, and if you're thinking about going multi-cloud, it's a really good way of doing it. I'm not going to go in depth on Spinnaker. I think there are plenty of sources that you could find on other talks for doing that. But I do think it's important to know that Spinnaker is a pretty important part of how we do multi-cloud deployments at Target, and historically it's been a big part of the TAP architecture in the past. So just to give you a really quick overview of what a Spinnaker pipeline looks like, essentially, the difference between pushing a Docker container in a script at the end of a CI job versus what Spinnaker does. Spinnaker is able to monitor the environment and notice that as an artifact is published to, let's say a Docker container is published to a Docker registry, a pipeline can be configured to observe when that's happened and then go off and run a series of steps. So in this example, you can see that a pipeline trigger kicks off a parallel job that deploys an artifact to one cloud, waits for healthy instances, disables the old server group, and then your code is up and running and it's in production, and it's all safe and the pipeline's complete. The story for how we use Spinnaker in our stores environment looks something very, very similar to this. Unimatrix is what we call the environment, and Unimatrix essentially presents Kubernetes API that in turn we're able to sync out to multiple stores. This is another one that's probably too deep for the 9 remaining minutes that I see ticking in front of me. But if you Google the blog post, I wrote a blog post a couple of years ago about our motivations for building Unimatrix and what it all means. In using Spinnaker to deploy out to our stores cloud environment, essentially we do that exact same thing. We do a pipeline trigger. We deploy out to 5 stores. Spinnaker lets you put tasks in the middle where it can do things like canary analysis or other kind of metrics observation to make sure that everything's okay. In the case of the stores, we do a manual judgment to say whether we want to proceed. Once we do, we deploy out to 10, and then we deploy out to 50, and then eventually, at the end of the pipeline, we have a chain-wide deployment. It was safe. It was good rolling, progressive deployment, and so forth. Okay, so talking about the 2 factors that we need. We need CICD and we need data movement, right? Most organizations are going to nail CICD and they're going to say, we did it, we're multi-cloud, right? But that doesn't actually speak very much to how we defined a true multi-cloud, which is that services and data are able to act cooperatively across multiple clouds. So that continuum of both the service deployment and the service operational footprint, as well as the data that goes along with the service, should be able to be spread across multiple clouds. So I'm going to start by talking about the Target Retail platform. In terms of data movement, maybe not actually surprising that DevOps and infrastructure can't do too much about pulling this off in a vacuum. There has to be application and service architecture that goes along with this. So I can't go, again, another conversation that we probably can't go too deep, but I can give you an overview. And if you go and look, Joel Crabb, who's the chief architect at Target, he's given presentations over the last 3 or 4 years about Target's microservice operation and all of that kind of stuff. So he's a really great way to go off and see that. But essentially, the Target Retail platform provides a way, defines a set of patterns that defines the separation of services inside the platform that provide core data, use core data, or aggregate core data at the end of the day. So it gives a really easy framework to product development teams to understand where they fit in the architecture and what constraints they have on how the data is used and how data is produced and so forth. At the very bottom of the architecture is core data, and you can see that essentially data, even though the arrows look like they're going the wrong way, data flows from south to north, right? So any requests for core data go to the core data APIs. The core data APIs in turn pull them from databases and so forth and so on. Some examples of core data in a retail environment are, you can probably sit down and imagine it, but things like item, price, location, so forth. So in other words, we have a product that we need to sell. We call that an item. An item has a price, an item has a location, et cetera, et cetera. There are distinct APIs and model contracts for each of the core data elements inside of the Target Retail platform. And that's really important for us being able to pull this off in a multi-cloud environment. At the mid-tier stage, you can see that we have aggregate APIs. Aggregate APIs are essentially responsible for talking to one or more core data and then giving that data back in a unified model. And at the top are the tenant services, which ultimately consume and make use of this. This is where the features live and the features come from. Now on the right, you can see a change event has taken place. And essentially, anytime that data is changed, a data change event is published out to a common stream, that anybody who's holding on to a cache of data or working with data is able to tap into that stream and get updates on this. And this is a really important concept for how we do data movement across the different clouds. If anybody's familiar with CQRS or similar event sourcing patterns, this is exactly that. Yeah, one such service that facilitates high-scale data movement for us is something called Autobahn. I don't know if Autobahn is open source at this point. There's been a lot of conversations about doing that, so that might be something to keep an eye on. But essentially, Autobahn is a hyper-efficient data movement platform that enables us to represent the core data and aggregate APIs and the corresponding data anywhere inside the hybrid or multi-cloud environment. And basically, as long as we have network connectivity between endpoints, Autobahn takes the guesswork out of making sure that data ends up anywhere that we're running portions of the target retail platform. It does this through a variety of mechanisms, but essentially it taps into that event source and reads update events and change events and delete events and so forth as they're happening, and updates an internal. It's more. I don't want to call it a cache because that kind of dumbs down what it actually is, but it's an internal representation of that data. And then essentially we can deploy out these facade APIs that represent that API contract. So a quick look at the Unimatrix environment, what this looks like. Every store is running a Kubernetes cluster. There is a Spinnaker pipeline to deploy out to one or many stores simultaneously. And then inside of it, we have tenant APIs. And then we have the core data APIs that Autobahn is responsible for standing up a facade around. All of these tenant APIs that are running inside the Kubernetes environment in the store also run out in the cloud. It's the exact, we literally deploy the exact same container between the cloud, the data center, and the store. Multiple clouds, multiple data centers, and multiple stores, I should say. Go watch John Engelman's 2019 talk on TAP. That's, if we had a lot more time, I could go into it. But a very quick representation on how that CICD and data movement portion matters so much to us. This is more or less what I consider Target's cloud continuum. We have multiple public clouds. We have multiple legacy data center as well as private cloud regions, and then we have a big stores block that obviously there's multiple stores. We're creating this thing called MAZE, which stands for multiple availability zones, which essentially is the next level for how we think about our edge deployments, and our edge deployments are our store environment today. So we have CI/CD and data movement across the entire spectrum of all of these things. So any service that you write is eligible to run anywhere inside this stack. So a couple of future considerations I want to talk about and want to dive into a little bit. If you go and watch John's talk on TAP from a couple of years ago, he talks about something called Pi. Pi is essentially the platform intelligence engine inside of TAP, and it acts as a broker for deployment. And it gives us a mechanism to essentially be able to granularly control the destination for a deployment. So all deployments are written to Pi. Pi in turn figures out what backend infrastructure it needs to run on. And because we have that target retail platform architecture, we're able to pull off deploying one service basically anywhere that we want to. So something we've talked a lot about in the past, and that we will talk more hopefully about in the future, is essentially using Pi to build a spot instance fleet, which is cool. Functions as a service, of course, is extremely promising inside of this world. There's a lot to talk about there, especially when we talk about expanding out the Autobahn data model. Sorry, not the data model, the data movement model for it, and allow it to provide bidirectional updates and automatically manage two-phase commits and event sourcing on its own, which would be very nice. And then last thing to think about for this world, We think a lot about the public cloud, and we think a lot about private cloud and data centers representing our cloud and runtime environments. A new thing that has evolved over the last couple of years is that now you can run code inside of the CDN. Most major CDN providers are allowing for functions as a service to operate inside of CDN environment. I think that's incredibly fascinating. It's not something that we've had time to dig into, but I think that could be another conversation in the multi-cloud world that maybe doesn't traditionally fit multi-cloud, but that's kind of where we are. And there we are. Thank you all very much. Appreciate your time and your attention. And thank you, Bridget, and thanks to all the organizers and sponsors of this event.